Okay, so today we're going to review one of each type of problem. This is a fence problem to start with. It's number 6 from the notes packet that we've been doing. It says you had a rectangular lettuce patch, 480 square feet in area. So area equals 480 square feet. It's going to be fenced off to protect it from rabbits. Find the least amount of fencing required if one side of the land is protected by a barn. So the only sides we're going to worry about are, we call this width and length. That's all I got to worry about. The barn is the other piece. Okay. I'm trying to find the minimum amount of length around that. Okay. So I'm going to call that perimeter, although it's not technically a full perimeter because we're missing a piece. But perimeter is going to equal 2W plus L. I just added up these three numbers here. Okay. I also know that area equals length times width. So in this case, 480 is length times width. And my goal is to minimize my perimeter. So that's what I want to start plugging stuff into, is this equation here. So I'm going to replace the L because it's kind of by itself. So length is going to equal 480 divided by W. So I will have my perimeter equals 2W plus length, which I'm going to replace length with this value, 480 divided by W. Okay. So I have that. That's what needs to be minimized. That's what needs to be minimized. Now, you can use your graphing calculator. I'm going to be fancy, and I'm going to use Desmos. And so for Desmos, the equation is 2W, or W is my x, so 2x plus 480 divided by x. Okay, so that has been graphed, and so what I'm going to do is I'm going to come over here and look and see if I can find it. There we go. So I'm looking for the minimum amount, which means I can just click right there. I get 15.492. So in my graph, x equals 15.492, and y equals 61.968. So now I have to make sense of what those dimensions are. Okay, well, it wants to know the minimum amount of fence required. This right here, the y value. Y is the output. It's my P, my perimeter. So this is the length of fence I need. That's the smallest amount of fence I could use to still get my area of 480. Now, X is W. It's my width. Okay, so this is 15.492. And so if I want to figure out my length, I have two options. I could say this equals 61.968 and then subtract 2W. That would work fine because this is W. What I'm going to do is I'm going to say 480 equals length times width, which is length times 15.492. And then just divide both sides by that 15.492. That's all I'm going to do. Okay. And so 480 divided by 15.492, I get 30.98. So my width is 15.492. My length is 30.98. And if they asked me for area, which they didn't, or length, total length, they didn't, but the total length would be 61.968 feet in this situation. Okay. Let's try another one here. So that was how we do our Thin's problems. Thin's problems are normally going to combine area and perimeter. Now, perimeter is always going to shake you because sometimes there's lines in the middle and stuff, but I call it perimeter sometimes. Now, an open box will be constructed with material that costs $7 per square meter for the sides, $13 per square meter for the bottom, and it has no top on it. It's an open top. So I'm going to go ahead and add a line right here so the box actually looks open. That way it makes sense to me in my brain. And I know the bottom, so the area of the bottom is going to be, well, it would be length times width, but in this case I got 2x and x. So the area is going to be 2x times x, which is 2x squared. And so the cost of the bottom is going to be the price they said, which is, for the bottom, it's $13. So 13 times 2x squared, which is 26x squared. That's the cost for the bottom of my box. Then for the sides, I actually have 4 sides. I'm going to color those in. So this side here is the same as this side on the inside, which you can't really see very well. Those sides are the same. And then this back side is the same as the front side. Those 2 sides are the same. Okay, so once we find the area for 2 of them, we can just double it and find the area for the rest. So the area here is going to be 2x times y, because this is a y height. This is going to be xy for that area. And so the area for my sides is going to be 2 times 2xy plus 2 times xy, which gives me 4xy plus 2xy, which is 6xy. So there is my area of my sides. Now the cost of the sides is going to equal the area times 7. So it's going to be 7 times 6xy, which is 42xy. So now we have our cost of the bottom, which is right here, and our cost of the sides, which is right here. And they said, what's the largest box you can build? Largest box, that means volume, with $300. So my total cost is going to be the cost of the bottom plus the cost of the side, which is going to be 26x squared plus 42xy. And we know that that has to equal $300. So this is a big equation for us right there. That's a big equation. So we've got to combine that with our volume equation because we're trying to maximize volume. So volume is going to equal, well, in this case, it's length times width times height, which is 2x times x times y. So my volume is 2x squared y. Now, we don't know what y is, but we can find y. All we have to do is solve this equation for y, get y by itself. So I'm going to take away 26x squared, that'll be 300 minus 26x squared equals 42xy. Then I can divide both sides by 42x. And I'm left with, those cancel out. So y equals 300 minus 26x squared divided by 42x. You could simplify that sum, but honestly, you leave it like that, it works just fine too. After we have this value, we can replace it in this equation, and this is going to become 2x squared times 300 minus 26x squared divided by 42x. Okay, so I could simplify. I don't need to. I can just graph it. You need the calculus, simplify all you want to, but right now, let's just graph. So go to Desmos. I'm going to have 2x squared times 300 minus 26x squared divided by 42x. Okay. If you look here, you can zoom in, you can see a good looking maximum right there. Trying to maximize our volume. I get 1.961, so x is 1.961. And y is 18.68. Okay, so let's turn these into words that we know. Okay, x is actually x there, which in our picture is there. So that's legit one of my sides. So 2x, because the question is, what is the volume? Okay, well, I could go ahead and find 2x. I could just double x. That wouldn't be too hard. But the output of this graph is my volume. So I don't actually have to know those dimensions. All I have to know is the volume, which I have right there, 18.68. So sometimes understanding what these variables mean in your graph really help because they allow you to do less work. You don't have to find all the dimensions. Only thing the question asked for was what is the volume. Now it also, I'm going to take that back. It did say find the dimensions, so do a little bit more work. So 2x is going to be 1.961 times 2, which is 3.92. I rounded a little bit, that's okay. And then for y, how are we going to find y? Well, we have an equation for y right here. So I'm going to put that in my calculator. Okay. And what I'm going to do is I'm going to store 1.961 for x. That way, all I have to type in is 300 minus 26x squared divided by 42x. And it saves a decent amount of time. I get 2.43. So I have my dimensions, 1.961, 3.92, 2.43, which is kind of my height, and I'm done. And I'm done. Okay. Next problem here. It's a cylinder problem. Now, it says here that they want to make a cylinder with a capacity of 1,250 cubic centimeters. The top and bottom cost 5 cents per square centimeter. The side is 3 cents per square centimeter. So find the dimensions that will minimize the cost and find the cost. So let's look what we got. Can I have a cylinder? And the top and the bottom cost 5 cents per centimeter, and the side is 3 cents. Okay, so I know the volume has to be 1,250. Also, the volume of a cylinder is pi r squared times the height. Now, I know my surface area is what's going to cost me money. So surface area is 2 pi r squared, because pi r squared is a circle, and there's two circles, top and bottom, plus 2 pi r, which is the circumference, times the height, which gives us kind of the area of a rectangle, if you want to look at it like that. Now that we have the surface area formula or equation, we got to remember that the top and bottom are 5 cents per square centimeter. So what I'm going to do is I'm going to multiply this by 5, and then it says 3 cents for the side material. Multiply that by 3. Now, what this will do will give me my answer in cents. It will not give me my actual answer in dollars. So once I find it, I have to divide by 100 to get my dollar value. So the total cost is going to equal 10 pi r squared plus 6 pi r h, and that will give me my cost in cents. Okay. Now, I can't graph this and find the minimum until I have one variable, which means I've got to replace my h value. So to replace my h value, I have h equals 1,250 divided by pi r squared. I got that from my area formula. Okay. Let's divide both sides by pi r squared to get h by itself. If they give you a volume, you're going to end up solving volume for a variable. If they give you an area, you're going to end up solving area for a variable. So whichever number they give you, you're going to use that to solve for h, or to solve for r, or to solve for length or something, okay? So I'm going to have my cost equals 10 pi r squared plus 6 pi r times 1,250 divided by pi r squared. Now, you don't have to simplify that if you don't want to. However, that's a really easy simplification. I know that the pi will cancel out with the pi, the r will cancel out with the squared, and then I know that 6 times 1250 is 7,500, just off the top of my head. And by that I mean there's a calculator sitting right here next to me. So 10 pi r squared plus 7,500 divided by r. That's my cost equation. I've got to find where that is the minimum. So I'm going to go to Desmos, and I'm going to type in that equation. So the equation was 10 pi r squared, now we're using x for r, plus 7,500 divided by r. Okay. Now, if you're home, one trick, if you have a touch screen, if you pinch on the y-axis and pull them together, it will shrink just the y-axis and not the x, which makes it easier sometimes to find minimums a little more quickly. Okay. And so I get x equals 4.924 and y equals $2,284, or sorry, 2,284.86. Okay. Now, this x is actually my r value. That's my radius. This is actually my cost in cents. So in dollars, that's going to be $22.85 if you round it like you're supposed to. Okay. And then if I want to find my height, I can go back over here and just plug in my radius. 1,250 divided by pi times 4.924 squared. So 1,250 divided by pi divided by 4.924 squared gives me 16.41. So I've got my height, I've got my radius, and I have my minimum cost, which is actually $22.85. Okay. Lastly, we're looking at a distance problem. Find the point on y equals x cubed closest to the point 4, -1. Now, if I draw like a quick graph here, I know x cubed looks something kind of like this. And 4, -1, so 1, 2, 3, 4, -1. It's somewhere over here, okay? So I'm figuring out where in this line or graph is closest to that point. Now, we're finding the closest, which means the shortest distance. So the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, we got to get rid of all these x's and y's and replace them as best we can. Now, I do know that 4, 1 is an x and a y. I'm going to call that x1, y1. So I'm going to have the square root of something minus 4 squared plus something minus -1. So it becomes plus 1 squared. Then I know I've got an x2 and a y2. Okay, well, actually, the x2 is just x. That's just an x value. But the y value is what I find interesting. Okay, the y here, this would be y, but we know what y is equal to. Y equals x cubed. So I'm going to take that y out of there, and I'm going to replace it with x cubed. And so that's my distance, and I want to minimize it. So we can graph the square root of x minus 4 squared plus y, not y. We replaced it with x cubed. Now, I'm going to be lazy. That's x times x times x, x cubed, plus 1 squared. Okay. And not a look at that. God knows how that square root did it. Say lovey. So I'm going to be lazy again. And I'm going to see if I can do it to the 1/2 power. That's a square root. Okay. Now I'm going to go back home. And again, just a reminder, a 1/2 power is a square root. And there's my minimum. 0.824, 3.538. So x equals 0.824, y equals 3.538. Now, this is not your point. Y is actually your distance. So the minimum distance that you can get, the closest you can get between those two, the graph and the point, is 3.53 cells away. Now this is my x, and the way I find my y is I know y equals x cubed. So 0.824 cubed is going to give me 0.559. So this is my actual y value. So the point is going to be 0.824, 0.559. Okay. So final answer. That is the closest point to 4, -1, and that is how far apart they will be. Is 3.538. When you answer the questions, please be careful. Pay attention and make sure you answer what they're asking, because sometimes they'll ask for a point, sometimes they'll ask for the distance, sometimes they may just ask for an x value. So be sure you pay attention. And good luck.